that is the end of the break, and I hope you guys take some time to think about the I would say the homework for the break a while. So is some people already figure out why we need to change this statement like this? It's okay? It's understandable for you guys? Okay. So I'm gonna do another. Should I do that? Should I get you guys another chance to get the bonus points if you can come up here and explain these two things in English? Is there anyone want to try that you can come up here? Yeah, I know probably no one want to volunteer, but I'm gonna ask anyway. So is there any people who are courageous enough to come up here and try to use English? Your English don't need to be perfect. I don't have perfect English as well, but you just need to try. So is there anyone want to volunteer to come up here and explain why we need to modify these statements in this way? You can get 1 bonus point for the entire course, okay? And this is the extra bonus points. It's not included in the 5% bonus point. Does anyone want to do that? 3, 2. Okay, I see some people smile at me, but I'm not sure what is the meaning. Do you guys want to try? 2.5? No, not 2.5. 1.5. 1. Okay, never mind. Okay, yeah, I know it's not an easy task, and yeah, so I just want to try. Okay, so without further ado, let's continue today's course. So before the break, we just introduced the combination between the increment operator and indirection operator and how we can use pointers to traverse an array. And then after the break, what we're gonna do is to continue the second topic. And actually the second topic is related to the first one. And the topic is using an array name as pointer. So here we need to reveal an important fact in C. And we haven't really introduced this fact when we introduce array. And the reason is that to understand this fact, you need to understand the pointer concept first. So that is why when we introduce array, we didn't introduce this important fact. So this fact is the name of an array can be used as a pointer to the first element in the array. So the first element is the first element, A0 here. I know it's pretty confusing here. So the first element is A0. For example, if we have an array A, integer array A, you have length of 10. If we just write down A, the name of array itself, actually the name of array itself, A, is treated as a pointer point to A0. So what it means is that the value of the array name is the address of A0, okay? So we repeat this a lot of time. In C, the address of the pointer itself is equal to the pointer to the variable. The address of the variable itself equals to the pointer to the variable. So if A is the address of A0, that means that A can point to A0. So that is why if we apply indirection operator to A, and then we assign 7 to it, this expression equals, what this expression do is to store 7 into A0, because A is point to A0. And again, if you understand it, then we can further apply the concept of pointer arithmetics on the array name itself. So we have array name A, and if we add another integer value to A, we can actually perform pointer arithmetics, right? So if we add I, let's assume I is an integer variable. So if add I to A, actually this is the same as AI. It's the same in the situation where we use I as the index number of array A, and this is the same as we get the address of AI, because A plus I itself is still a pointer. So this is the figure for AI. So A will be the pointer point to the A0 here, and let's assume if I is 1, so A plus 1 will, this expression altogether will produce another pointer, and this pointer will point to A1. And again, we need to remember the address of the variable equals to the pointer of the variable. So if the value of I is 3, then A3 will be A plus 1, A plus 2, A plus 3. So A plus 3 will point to this element. And furthermore, we can even apply the indirection operator to this pointer, because we say A plus 1 altogether is actually one pointer, right? This is one pointer. So we can, of course, apply indirection operator to pointer. And actually, this is equivalent to AI. So another way to think about this is that, as we know that A plus I is the same as the address of AI, right? Because A plus 1 points to this element. The pointer of the variables equals to the address of variable. So of course, A plus I is equals to the address of AI. We also talked about this in the slide here, right? So if we applied the indirection operator to A plus I, actually this is the same as we apply indirection operator to and AI, and we also say that the indirection operator and the address operator can have the inverse relationship. So that is why we can just course the address operator and the indirection operator, and we can get AI. So here, the example here, just to demonstrate this relationship here. So in the previous example, we talked about how we can assign 7 to star A. So this is that we assign 7 to A0. And we can also get A plus 1. This is another pointer. It points to A1. And then we apply the same indirection operator, and we assign 12 to this. So this statement, well, what this statement will do is to store 12 into A1, because A plus 1 is equal A plus 1, and then if we apply the indirection operator to it, it equals to A1. So we just assign 12 to A1. Okay, can you guys still keep up with the slide right now? So there are a lot of new things here. The first, we need to remember the array name is a pointer to the first element of the array. So that is why we can apply pointer arithmetics on the array name. And the following things, we just follow the same concept of pointer arithmetics. However, the other thing we need to know is that the relationship between the expression of pointer arithmetics and the expression of array indexing. So actually, these two things are pretty similar because they are the same. So you need to know how to transfer from this expression to this expression. because we are familiar with this expression with the array indexing, right? Okay. So if we can use this fact, that is the array name is the pointer, it can help us to write the loop that step through an array easier. So let's check out the example here. So we talk about the, okay, actually I should change the expression here a bit. Sorry about it. Okay. So let's go back here. So in the original for loops, we write down something like this, right? We can use P to traverse array A and then get the value of elements and add it back to the sum variable. However, now we know the name of array A itself is already a pointer and it points to A0. So I can revise these original for loops into this. So this is a simplified version. So this for loop do the same things, but this one is simpler than the original one. So we can directly assign A to P because the name of array itself is equal to the address of A0. And here we can use another expression for this. Instead of writing the address of n minus 1, we can use the pointer arithmetics to get the address of the last element in the array A. And the rest is the same, but this one is definitely simpler than this one because we don't need to write down the address operator again and again. However, there are some limitations for the array name. Although array name can be treated as a pointer to the array, but we cannot assign a new value to this array name. Unlike any pointer variables, we cannot change where A itself is pointing to. For example, if we trying to increment A, if we trying to use A, the name of the array, to traverse the array itself, you will get the compilation error. So that is the design of C, because C wants the name of an array always point to the first element of array. So we cannot change the value stored inside the name of array. However, we can always copy the value stored inside the name of the array to another pointer variable, like the pointer variable P. We can copy the value to P so that we can make P point to A0. Then we can use these for loops to increment P itself to make P point to another element in the array so that we can traverse, we can visit all the elements of the array using P. And now, maybe some of you will think about one thing we talk about when we introduce array, that is when we use array as argument for a function. We kind of say that, if you still remember, we say that if we use array name as the argument, we can actually change the value inside array in the function, right? So now you know why we can do that. So the fact is that when we pass the name of array to a function, what we pass is actually a pointer to the function. And this pointer is point back to the first element of array. So that is why whenever we do to the array in the function, will reflect back to the original array. So in this example here, we have array B, and we have a function called find largest. And the function have two parameters. The first one is array A, and the second one is the integer variable n. And then what this function will do is to find the largest value in this input array. And we can actually call the find largest function by using the name of array B and the length of Bn here. And we can now know that the first argument B is actually the address of B0 here. So what happened here is that we pass B to the find largest function, and what will happen is that we will copy the value stored inside B, that is the address of B0, and assign it to A. So we make the name array A, the name of A, the name of the array A, also point to where B is point to. So A now is also point to B0. So you can see in this case the contents of array is not copied. What we copied is the address of B0. We just make A point to the B array. So in here you can see that the C actually treats the array argument as a pointer. So we can use this fact to do the following things. So there are some important consequences in C. So the first thing is that so we all know that if we have the ordinary variables as the argument, when we pass an ordinary variable like the integer variable to a functions, what we do here is to pass by value, right? We copy the value of the variable and then assign the value to the parameter of function. So that is why any change to the parameters doesn't affect the variable in the argument list, right? We talk about this when we introduce function. However, because the array argument itself is actually a pointer, and if we pass the pointer to the function can actually change the object this pointer point to inside the function. So that is why the array argument is not protected against change, because the function can indeed change the contents of the array we pass to the function itself. Just like the example here, we pass the array B to this store 0 function here, and in these functions, what we do to the array A will reflect back to the array B. The reason is that A is actually point to the array B. So again, if we don't want the array parameter to be changed, we need to use the constant in the parameter declaration. So we talked about this in the previous course. So when we define a function and we want to protect the one parameters that we don't want the function to change the value of the parameters, we can add the constant here, this keyword. So this keyword will tell the compiler to check that in the function there is no assignments to the parameter. There's no change to the parameters that have the declarations with const. So this is one thing to protect this function to change the array we pass to the function. Because sometimes when we pass an array to the function, for sometimes we just want to use the value stored inside the array, but instead of changing the value of the array. If that is the case, the best practice is to add const to the parameters for that array. Okay, so that's go to the second consequence. So the second consequence, we actually already talked about this. So why we want to have this, why C have this kind of design, or why we want to pass the name of the array to the function, what is the benefit of it? So actually the benefit is that the time required to pass an array to the function doesn't depend on the size of the array, because what we pass to the function is not the array itself, it's just the address of the first elements of array. And the size of address is always the same, no matter how large the function is. Because you can imagine that, for example, in here, if the function have the length 10,000, and if we want to pass the entire information of this B array to the functions, your computer, our program need to spend a lot of time and memory space to copy and pass the value of the entire array, right? However, in C, C only allows you to pass the name of array to the function. So the name of the array is the address of the first element of array. So what you pass is not the big chunk here, it's just a small chunk here. And no matter how big this array will be, the address will still be the same. So you just pass the address to the store 0 function, and you have the parameter A. You let the parameter A, the name of array, point to the first element of the B array. So that is the, I would say the one of the benefits of you using array name as a pointer. Then the next consequence is that now we know that the array parameters is actually treated as a pointer to the array, right? So actually we can change the declaration of the parameters from this, from int a and then the square bracket from this version into this version here, because we know basically it itself is a pointer point to the first elements of the input function, right? So we can declare a to be another integer pointer. So in C, actually the int a squared is equals to, sorry, I forgot to add an int here. So these two declarations are the same. And compiler will treat these two declarations identical. They are the same declaration for C compiler. So that is why in some place, maybe you will see that some C programmers like to write down the integer pointers to get the how to say that? Okay, let me try it again. So that is why you will see that in some C code, instead of declaring array parameters, they will just declare integer pointer variables or the pointer variables to get the input information of array. And the next consequence is that we can actually pass a part of array to the function instead of the entire array. Because now we know that the name of array is a pointer, right? But we can create pointer to any element of array, right? So we can use this fact to write down a program like this. So here we have an array B, and the length of B is 20. But in this case, I only want to find the largest number after B5. So instead of just write down B here, I can write down the pointer point to B5. So I just apply the address operator and get the address of B5. So we will assign this value, the address of B5 to A. So A will now point to B5. Then we can apply the find largest function only to the element 5 through 14th of array B. Okay, and through 14 is that in this case, I only indicate there's the length of 10. So the n will represent the length of array. And I can use these two parameters here to control the part of array this find largest function can see. So for the find largest function, the first element that A is pointing to is B5, and the length of this array is only 10. Okay. So for now, maybe you will find out that in C, the array index is kind of very similar with the pointer to array, right? So the next things I would say is also important is to remember, actually C allows us to apply array index to a pointer variable when this pointer variable is pointing to array. So what does this mean? That means that we can treat the pointer variable point to the array as a new name of the array. So we can just check out the example here. So in this example here, we have array A, and we also have a pointer variable P, right? And we assign A to P, so we can make P point to A 0. And here, actually, we can just treat P as a new name of array A. So I can use the array index technique to P. So I can just write down, instead of using the pointer arithmetic like this, I can just apply the square bracket with I to get the I element in the array that P is pointing to, just like P is the name of the array. So that is one thing we can use in C. And please remember this important concept because we will use this concept in the next lesson. So that is all for today, and we introduced a lot. So I will encourage you to just trying to review what we taught today, and you can write down this example code on your computer by yourself. So that is all for today, and thank you for coming.